Let's see the example here. Let's do this example. You have integral of 4x squared plus root x dx. Let me write this as simplified form. Since this is a constant, okay, so you can pull that out. That's what this says, right? If there is a constant multiplying to a function, you can pull that out and then find the integral of that. So you can write 4 and then integral of x squared dx plus, you can distribute. Since there is a plus, you can distribute this. If there is a product, you cannot distribute. You cannot do integral of 4 times integral of x squared, but you can do for plus and minus. If there is minus as well, you can do plus and minus there, okay? So here you can do integral of, what is root x? Root x is x to the 1/2 dx, right? If you simplify this, if you use the formula here, what do you get? 4 times, what is x squared, integral of x squared? It is x cubed over 3, right? Plus c, plus, what is the integral of that x to the 1/2? It is x to the 1/2 plus 1 over 1/2 plus 1 plus another c, right? Another constant c. So what you write here is, you can say this is c1 and then this is c2. This is the first constant you got from here and second constant you get from here, right? So what do you do with that is simplify. You got 4/3 x cubed, right? Because 4 over 1 times 4 times x cubed, 4x cubed over 3, or 4/3 x cubed. I will combine c1 and c2 and then I will write plus c at the end. So you don't have to write c in every term. What you do, you'll write a plus c at the end. Okay, plus, what is x to the 1/2 plus 1? Is x to the 3/2 over 1/2 plus 1 is 3/2, right? And then plus or c, because I added c1 and c2 and I wrote plus c there. So if you simplify this, what you get is 4/3 x cubed, right? And then plus, I want to write this in nicer form because it is like this function, this term divided by a fraction. So what you can write is, you can write 2/3 and then x to the 3/2 plus c. So this is the final answer. How do I get that 2/3 here? Because it is like, if there is a over b divided by c over d, how do you do that? You write the top fraction times, you write the reciprocal of the bottom fraction, you do d over c. So basically you'll get a d over bc. That's what you get. So I use that formula. So let me erase these terms to write the second example, okay? Okay, how do I do the second example? Because all these formula needs the function to be on the top, not on the denominator, right? Everything here, it is written in the top. The bottom is just 1, right? Like secant square x over 1, sin x over 1. That's why. So if there is something on the bottom, you should move that to the top. So how do you do that? Since 1/4 is a constant, you can pull that out. 1/4, and what is left is x to the -2 dx. You understand that? I moved this x squared to the top, but 4 I pull that to the front. So what is the formula? X to the n has x to the n plus 1. So there is 1/4 already. X to the n plus 1, -2 plus 1 over -2 plus 1 plus c, right? If you simplify this, what do you get? You get 1/4 x to the -1 over -1 plus c. And if you simplify this, you will get -1. 4 times -1 is -1/4 times, and then this x to the -1 goes to the bottom with making x to the +1, right? So 1 over 4x plus c is the final answer. Number 1. How about example number 3? There are two terms, but they have the same base. X to the 1. What is this? What exponent of x is root x? X to the 1/2, right? So you can write integral of 1 over x times x to the 1/2, right? dx. So how do you do that? Is 1 over x to the 3/2 dx, right? So you can move this to the top because there is no formula that we can apply that has x in the bottom, right? So you need to move that to the top and use that formula. You will get integral of x to the -3/2 dx. Now use that power rule formula. x to the negative 3 half plus 1 over negative 3 half plus 1 plus c, right? After you use the formula of the integral, then you write plus c. So what is that? X to the negative 3 half plus 1 is how much? X to the negative 1 half, right? You can use calculator. Or it is negative 3 half. Is there a 3 halves? A 3 negative 3 half, and then plus 1 is the 2 half, right? So you can subtract that way. So it is negative 1 half plus c. If you simplify, what do you get? This 2 goes to the top and the negative. So negative 2 and this goes to the bottom over root x. You see that? Plus c. This is just the simple algebra trick. You know how to do that. Alright. How about example number 4? How do I do this? For this problem, you do integral of 13 dx minus integral of x dx, right? So do you remember how do I find the integral of a constant? Integral of a constant has, where is that? Integral of a constant, formula number 2, right? It is kx plus c, kx plus constant. So here k is like a 13, so it will be 13x. So I will write the constant at the end, okay? Because I'll get one constant from here and another constant from here. So I will combine those two constants and write a single constant as c, okay? So this will be 13x minus, what is the integral of x? Integral of x will be x squared over 2, right? Because see, so integral of x is x squared over 2 plus c. Or you can see that this is x to the 1, right? So x to the 1 plus 1 is x squared over 2. And then plus a constant you will get from here, another constant you get from here. I write a single constant by combining those two constants. That's the answer. Okay. How about here? We have the 3 terms, right? You find the integral separately. So how would I write this? Is I would write x to the 3 half and then plus I would write, oh, dx. I should not forget dx. 2 and then integral of x dx plus integral of 1 dx, right? That's how you write. And then use the formula. What is that? X to the 3 half plus 1 over 3 half plus 1, right? Plus 2 times x to the 1 plus 1, right? X, because there is x to the 1. So x to the 1 plus 1 is x squared over 2 plus c, but I'll write that the whole c at the end. So plus the integral of 1 is x, because the derivative of x is 1, that's why integral of 1 is x. And I write plus c at the end. That c is the combination of all the constants you get from each term. So what do you get? You get x to the 5 half on the top, but in the denominator you will get 5 half. If you want to write in the nice form, you write 2/5 on the top, right? This cancel out, so plus x squared plus x plus c. This. How about here on example 6? See, there is x in the top, x in the bottom. How do I simplify this? Because I don't want x in the denominator, because none of these formula have x in the denominator, right? So what I do here is I split the denominator, x over root x plus 6 over root x and then dx, right? Now, how much is that? You can just split the, distribute the integral, or you can distribute later, but let's simplify first. How much is this? This is x to the 1 half, right? You move this to the top, you will get x times x to the negative 1 half, right? And then plus 6 times x to the negative 1 half. And then there is dx. See that? If you simplify, you'll get x to the 1 and then minus 1 half will be x to the 1 half plus 6x to the negative 1 half dx. You see that? Now I distribute the integral x to the 1 half dx plus 6 integral x to the negative 1 half dx, right? So what is the integral of this? Is x to the 1 half plus 1. I'm using the formula number 3 again. So you get x to the 1 half plus 1 over 1 half plus 1 plus 6 x to the negative 1 half plus 1, right? Whatever exponent you have, when you find the integral, you add 1, okay? Negative 1 half plus 1 and then plus c, right? So let's simplify that. You get x to the 3 half, because 1 half plus 1 is 3 half. You will get 3 half on the bottom, but I will write 2/3 on the top, okay? Plus, what do you get here? there is 6 and you'll get 1/2 here, right? Positive 1/2, because negative 1/2 plus 1 is positive 1/2. But when you write in the top, you'll get 6 times 2 is 6 times 2x to the positive 1/2 plus c. So the final answer look like this: 2/3 x to the 3/2 plus 12 x to the 1/2 plus c. This is the final answer. Okay, guys. So here, just one more time, what we do is you will get negative 1/2 plus 1 is positive 1/2, but then 1/2 is in the denominator, right? If you want to write in the numerator, it will be like just 2. 6 times the reciprocal of 1/2 will be 2 over 1. That's why I got 2. Okay, that's why. Next, we'll do example number 7. Let's do example 7. So here there are two functions. One is the cosine x, another is the sine x function. So I will distribute the integral sign. I'll write 5 cosine of x dx plus 4 sine x, integral sine x dx, right? So what is the integral of cosine x? It is like 5. It is sine x, because the integral of cosine x is sine x, right? This one. And another integral is of sine x is cosine x. So 4 negative 4 cosine of x plus c. You see that? Integral of cosine of x is positive sine x, but integral of sine x is negative cosine x. So I multiplied that negative with 4, so negative 4 cosine x. That's what you get. Alright, guys? Let's do example 8. So this is equals to, because you cannot distribute that integral over the product. You cannot write integral of secant y and then times integral of tangent minus secant. That product will have a product rule like we call integration by parts later. But for now, what we do, you simplify. You get secant y tangent y minus secant squared y, right? If you distribute that secant y, multiply it to both tangent y minus secant y, you will get that dy. Now what I do is I distribute this to both of these. So integral of secant y tangent y, and then my dy, and then minus integral of secant squared y dy. Can you tell me what is the integral of secant y tangent y? Where do we have that? Maybe I forgot to write that one, right? Oh, there is. So number 7, secant x tangent x has secant x plus c, because the derivative of secant is secant times tangent. So it is like secant y minus, what is the integral of secant square? Meaning, what function has the derivative secant square? That is that one, right? Number 6. So secant square x dx is tangent x plus c. So it will be tangent y plus constant. You will get one constant from here, another from here, but I combined those two and I wrote a big c, that is plus c. So that's the final answer for this. Okay, guys? Thank you.